Okay, for people who are joining this live stream, we are looking at language development for Wolfram language, and our topic today is trees. And we just had the joke that this is a monothematic meeting, and I was saying, but it has many branches. Okay. You know what? I have a big computation that's running in the background. Let me kill that off because I think it's gotten as far as it's going to realistically get.
Can you open this in the prototype build?
Oh, okay. Well, in that case, I don't even need to kill off the thing I was doing.
Perfect.
In the spirit of the meeting, you might want to chop it down.
What, the thing I was doing?
Oh. Yeah.
I'm trying to solve a 100-year-old problem, which is being quite recalcitrant.
I appreciate the pun.
Okay. There's a lot of beeping in the background there. Okay. Okay. Practical question: Who is working on trees? Who is the? Is it? Go ahead.
So now Ian.
Okay. So, yeah. And why do I think that Tony is working on them? I'm wrong.
At some point, we thought Tony would be a good person, but he had other projects to work on.
Okay. So, what is he working on? He's working on the entity extension stuff.
Yes, indeed. Yes. Faster framework. Exactly. Yes.
Okay. All right. Okay. All right. Yes. Should I look at the guide here?
Yes, I think so. So the main change here is that since the previous time we looked at it, we have changed to using the data structure tree.
Oh, nice.
Yes. And this provides a much faster capability. And also, because users will have access to the data structure itself, they will be able to do things with the compiler, it's trees new, not trees.
Okay. Sandra on the live stream is asking if we have any arborologists in the team here, and I think the answer is that the really crazy answer is I think we do have people working on things like that, but not in this part of the company. Okay, wait a minute. Trees new. Okay. By the way, there was an application of this that came up just yesterday in machine learning strategy meeting, decision trees. They have a representation for decision trees. I told him to go talk to Tony because I was confused. So somebody should unhook that. That's Jesse in machine learning.
Sorry, I think you need to update this file. Roger changed a few things this morning.
So how close? I mean, it's been a while since I saw this design. So,
right. So I think the first thing we want to discuss with you is the overall functionality, the syntax, etc.
Oh, you know, this is bullshit, if I might say so. We've got a function called tree plot. We're playing a silly game here where, no, we're not going to do this.
Yeah, so this is the sort of thing we want to discuss, because the point is that rules tree returns a data structure. And so like graph, probably we want to do something better with it.
We want to auto display it.
Right, exactly.
Up to some size, probably.
Yes. But the point of this meeting is not the actual visualization. It's more like the design of the functionality itself.
Okay, so the wrapper is what? There's a tree wrapper. That is what this actually returns. Is that correct?
No, it's not. It's a data structure.
It's a data structure.
Yeah, if you remove the tree form, you'll see a data structure.
Well, that's not right. I mean, I think we should specialize it. Right, that's not right. This should be tree, just like it's graph. The fact that graph internally, one day graph internally will probably have a compiled data structure. Do you understand what I'm saying?
Mm-hmm.
And so should this. I mean, this should just be tree of data structure. I mean, if you want it just be this data structure, fine. But the tree thing would display as a tree.
Right.
And if you wanted to, it might have an accessor that allows you to go get the raw data structure if that's useful, etc.
Right.
I don't think that's right. I mean, right, we've been through this before, right? That things that lie about what they are a problem.
Well, that's what we do for graph, and graph is extremely successful.
But
It doesn't lie about what it is.
Graph is its own unique data structure, and as a result, it doesn't play with a lot of things, right?
Well, I understand that, but I mean, it's this thing here, right? If I say, what's the input form of that? Okay, it's some weird thing here. Personally, I'd be much happier if this just said graph of data structure, blah, 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 and maybe a little bit of metadata.
Right. But data structure is a specific thing, right?
Yes,
I know it is, but that's not what this is making. This is making a tree. It's not making a data structure. If you want to make a tree data structure, that's a different thing. And getting the tree data structure from the tree object is a fine thing to want to do, but the main thing is a tree object.
Right. Yes, so we agree on that. So we need this wrapper, which in the past was called tree element. And that's one of the things we want to discuss with you today.
Okay.
But yes, so everything related to visualization and the output form is, we know it's not ready. It's the main structure of all these tree extract paths, etc., that we need to discuss.
Yes. I really liked some of what we had developed, the design we developed before. I mean, I really kind of like the rules tree rules. It seems a bit silly, but I actually think it's going to be very easy to remember.
Indeed, we use it a lot for construction.
Right. Okay. Oh, nest tree, that's interesting. That's the analog of nest graph.
Exactly.
Which I hope is going to have its let's not make the same mistake here that we made with nest graph of having list elements can be lists. Don't get that confused. Nest graph has some nasty bugs, which Charles is right now fixing, to do with cases where the elements themselves are lists. Do you understand what I'm saying? Ian, you understand what I'm saying?
I think I get where there could be a problem there.
Right, but so just avoid it.
Yep.
Okay, one issue here. It's is handling of heads.
Yes.
And I think we'll need some options to determine whether you want the heads compressed into nodes or whether you want the heads separately followed.
So yeah, that's currently being handled with the second argument.
I see. I don't, in what way?
So there are named structures for what you want to use as the data.
Oh, I see. That's nice. That makes sense. Makes sense.
What's the one that sort of heads goes to true?
So the default one is head trees, and you can just have one argument.
Oh, wow.
And this will need a ton of work. If you try very hard, you're going to break the visualization.
Yeah, okay. I mean, because that has to have a vertex.
And so what's literally happening here is that the root of this tree, its data is itself a tree.
Yeah. Yeah. I understand. By the way, in terms of tree visualization, just like text structure has that way of visualizing with the big overbars, we definitely want that as an option here.
Yep.
And we also need to think about what the future of tree form is. Which might be just being folded into this stuff. Okay, so let's take a quick look.
But no. Tree form doesn't change anything. I mean, maybe tree plot goes, or whatever it's called.
Well, tree form is a question.
Tree form is a formatting wrapper. Which
I'm well aware. I'm just saying that it should use the same conventions and probably the same code here. In other words, what tree form should do is just call this tree object, this expression tree object, even though it's a wrapper, right? Even though it doesn't change its content in terms of functionality.
Expression tree is not a wrapper.
I know it's not a wrapper. I'm saying tree form as a wrapper, its format value should be something related to expression tree. Do you see what I'm saying? It's format.
Something that we had discussed in the previous iteration of the project. And the main idea is to avoid the confusion that we have in extract of whether a list means a list of positions or a single position, which is a deep position. So this avoids the ambiguity.
I understand it avoids the ambiguity, but at high cost. Because
Yes.
I'm not sure that that cost is worth it. I mean, I think the question, you know, the single level tree extractor seems like a rare thing to want. But okay, let's take a look at what we're doing here. Okay, so here, great, you could extract down to a certain subtree. Okay, tree cases of that tree is showing what the payloads are that match this pattern, right?
Exactly.
Right.
But now I see that pattern could itself be a tree. Is that correct? If tree cases wanted to match subtrees, what would you do?
I don't know, and I don't think you could just pattern match to the tree.
Well, but so why?
So the previous tree cases with the tree element design allowed you to have like a tree element pattern there in the second argument, and would try to match the tree.
Yeah,
I'm not sure how to do that with this, and so tree cases, tree position, and tree count exclusively look at the data.
Well, that's not that interesting.
And tree select looks.
Yeah, but so we don't want that. We want something which can match a subtree.
I agree.
That's why we invented the previous thing. So,
well, what we need is a pattern that can match a data structure.
Indeed. But look, you're obsessing about the data structure here, right? This is a particular data structure. The fact that we implement it as a data structure is our business, right? Mm-hmm. What we want is a pattern. And yes, there may be special code to match a data structure pattern, but that's not the main point here. Let's have a quick look through what you've got here. So one of the steps backwards is not being able to match subtrees, right?
Yep.
Right.
Okay. Sandra is asking about functions for siblings, which I believe we do have. I hope we have. We had it before.
Yes, for extraction and referring to them. Yeah.
They're planned. It's not implemented.
Okay, so why is this tree insert not using? You see, this is you just lost your tree path, because this. Why doesn't this use a tree path, right?
Well, that's the thing it's inserting. The
syntactic sugar that's equivalent to tree path of 2.
Sorry, what's equivalent to tree path of 2?
In the third argument where you have 2, that is just equivalent to saying tree path of 2.
I understand that it's equivalent to that, but this is illustrating why you don't want tree path. Because, look, I mean, tree path could have a role like key in associations, which is rarely used, but not used when you need to use it. And also, I have to believe that tree insert, like replace part, should have, and insert, right? Insert has, if I'm not mistaken, if I say ABC 2 arrow X, that doesn't work.
You're wrong.
What's that?
I was going to say you're wrong. Insert, delete. I mean, insert is like delete, right? You give the position and then you give the payload separately.
But I think that would be a reasonable syntax given the replace part story. I think that would be a nice syntax. It would be helpful to, I mean, it's not particularly profound, but it's a helpful syntax, it seems to me. I would recommend that we support this syntax, but for trees, it feels like the right thing to insert. I mean, so is there a tree replace part?
Yes.
And it isn't just replace part.
Correct. It's the analog of tree insert.
Okay, let's take a look at some of these. Okay.
So the main idea of tree element was that it was very nested, which it may be useful for manipulations, but it gets very slow.
Well, I don't understand. I mean, the implementation is through data structures, right? The question of the exposure is a different story. So, I mean, right now, with one of the issues is the tagging of a tree head, a tree node, right? So in an XML element, there's, we understand that there's tags associated with that element. So how would that work in your representation here? You just have an expression at every node is just an expression, correct?
Yep.
Okay. And so we're not identifying. I'm very confused here. The node is an expression and its siblings and its descendants, right? Just like tree elements is the data and the subtrees, right? This must be the same thing.
Yep, essentially, yes. The data structure contains the payload and the list of children.
Right. So why isn't it just tree elements? I mean, don't tell me anything about implementation, because that's not, conceptually, I don't understand why it isn't just tree elements. Do you understand what I'm saying? If we had tree elements, then we could use that for matching and so on. What that compiles into is a different story. Am I making sense?
I think I understand what you mean, but we want something that is able to perform fast enough.
Guys, do you need me to do the software engineering? It's not very difficult. All you do is the outer tree element turns the inside stuff into an opaque tree object, tree element which has the data structure. When you go and you use these functions, they compile the pieces so that they operate on the data structure, right? We're not saying if you go in raw and you start doing part extraction and so on, it's perfectly reasonable for this to be a raw object. Do you understand what I'm saying? Which has its own tree extractor functions, not part extraction. Do you see what I'm saying?
I think so.
Yep.
Okay. So I mean, because this is the as if it was this. It doesn't need to be this. It's just as if it was this. Because this would give us, I'm not sure. It needs a little bit more thought, but to me, that seems like the right thing.
Yeah, I think it needs a lot more thought, right? Because, once you compiled it, right? I mean, is that tree element still there?
No, it's not.
Right. See, so
it's not still there. But Itai, look, the question is,
not as simple as you're saying it is.
What's that?
Not as simple as you're saying it is.
No, but it's not what should determine the design.
But it's not that simple.
Right. It shouldn't determine the design.
That we agree. Yes.
Okay. So, I mean, the main issue is if what we want. Okay. At some point, there is an expression. I don't care what any of these things are, right? The nest tree and whatever it is, right? In the end, there is a thing I could type in to get this tree. What is that thing right now? I mean, this is making a tree from rules, but I want to know, what do I type in raw to just get a tree? If I want to specify the tree in its own terms, what do I type in?
In its own terms? What do you mean by that?
I mean, this is a constructor for trees, right? I don't want a constructor. I want I want to specify step by step the actual tree.
Right. I understand that to mean you would need the tree element.
Fine. Then that's what tree element's role is. It is the symbolically specified every detail of how the tree looks, not a constructor for the tree from other expressions. Right? And you can think of it as a constructor itself. Just like rules tree is a constructor, so the outer tree element is also a constructor. I mean, it's conceivable that we want an outer wrapper called tree that is an outer wrapper on the outside, even of the tree element stuff. I think we had discussed that before. Right? I think that was the original design we had, was an outer wrapper of tree, and then its innards were all tree elements. But I think we decided we didn't need the outer tree wrapper. It didn't need any separate metadata. Am I right?
Right. The last design we had was just tree element nested.
Right.
of time.
So that may work and may not work. Clearly, if we had an outer tree object, then that outer tree object is the thing that performs the data structure level construction, that takes those tree element things, just like rules tree takes these things and packs them into a data structure. You see what I'm saying? Right? So if we had an outer tree thing, that's what it would do. Now, the issue is there are various things that we need to be able to do. Like, for example, we would like to be able to match, as soon as we have any tree, like for example, here's a tree I could make. Okay, let me make a tree. All right. I'm going to just make a tree that says A blank goes to B blank 2. Okay, there we go. Now I have a pattern tree. I want to be able to, to take that pattern tree and match it with tree cases, right? Do you understand what I'm saying?
You want to look for subtrees in.
I want to look for subtrees, and that has to work. That is a natural thing that should work. So any tree construction that involves patterns like this should be able to be thought of as a pattern, and tree cases and so on should be able to extract with it. Does that make sense?
Yes.
Okay.
Well, this is an idea that doesn't exist in graph, and that's a bit worrying.
Let me think about that for a second. Hold on. Let me think about that for a second. Actually, it does exist in graph. It is graph rewriting. And that's what we have all of these Wolfram model physics project things doing. It's quite non-trivial, but we actually have, very good code for that now. You see what I'm saying? But it's quite complicated in the graph case. The trees case is much easier. The graph case, this is precisely what you're doing in the graph case, is a match for a graph, for a pattern graph, is precisely, if you look at, in the theory that there's actually no new idea ever, right? I mean, if you look, for example, I'm pretty sure the end of this. Basically shows, okay, so this is, this is precisely doing this. This is, yeah, I mean, it's exactly this problem. There it is.
But there are no patterns anywhere in there.
There's the pattern. There it is. There's the pattern. Okay, it's not done in a graph because we don't have that capability. I'm just saying that this is what we are implementing here. See what I'm saying?
Right. I understand that the operation is certainly possible. I'm thinking about the design language.
Right. So I mean, this is a graph rewrite. Okay, those should have blanks on them. Okay, and it has a module on the right-hand side because it creates a variable. Okay. I'm just telling you, this is pretty non-trivial, this graph rewriting stuff. And yes, here's why it's non-trivial, okay? It's the whole story of multi-way systems, and in fact, the story of quantum mechanics, as it turns out, is the fact that there are many different ways to do this graph rewriting, right? For any given graph, I wasn't expecting to show this in this meeting, but for any given graph, right, this is a graph rewriting process, okay? And there are many ways to do that rewriting, you see. Actually, that's a causal graph, so I don't even know where the graph rewrite. Yeah, these are, look at that graph there. Those are the 3 rewrites that can be done on that graph there. Okay, so that is not a problem that you have in trees. Trees are unique rewrites, I think. Yes, they are. Right? Unless
if you're assuming you're matching from the top down.
Right. Which I think is a good assumption. But the whole point is, It's very important distinction. They are unique rewrites. As soon as we're doing graph rewrites, it's not unique at all. And it's very complicated. I mean, specifying which of the graph rewrites to do is even more complicated than specifying in an expression which, when you do evaluation or recursion through an expression, which thing to do, which is itself very complicated and we've never really resolved how to do. So I think it's a very good assumption that we go, that the tree matching is from the top down when it's nice and unique, just like expression matching is unique. You see what I'm saying?
Can I ask, so would that pattern there, would that only match a tree with exactly 3?
No, I think that's the question for tree position, right? Tree position would match this. It's just exactly the same as the difference in replace and /dot, for example. See what I'm saying? Replace only matches the whole enchilada, and replace replace all goes to everywhere. Am I making sense? And we'd want the same thing with tree replace. We want to do the same kind of thing, I think. Again, I haven't thought it through completely, but it's the same exact story.
The
Right?
general problem we always have in trees is the distinction between the subtree and the payload of the root. So we always have to specify, are you trying to match the payload or are you trying to match the whole?
I understand. And that's exactly why we need tree element, because tree element clarifies that. And in this particular case, this rules tree has to have a rule for how it turns itself. Every tree has to be thought of as if it was made from tree elements, right? Because every tree has to have, at each node, it has to have the node payload and the subtrees. Am I making sense?
Yep.
And rules tree may construct something. I don't know what the convention is for what this means, right? I'm assuming that the convention is this is the payload at that node, right?
Right.
And that this is the subtree elements.
But
Nick is pointing out how a tree rewrites unique. Okay. Several people are pointing out that I may be wrong about this. Okay, so hold on.
Well, they're unique up to the canonical search order, right? We have defined the canonical search order for replace all, which is top to bottom, left to right at each level.
Yes.
And so within that framework, that defines a unique, consistent search order for a tree.
Okay, but now, right now, and we had that in the previous design, we can also have named edges here, right? In other words, or is it the case that these are positional, in the previous design, we had the idea that tree elements could either be a list of tree elements or an association of tree elements, right?
This is just a list of...
I understand that, but I'm saying it should also be able to be an association of tree elements. Now, don't bleat about how data structure doesn't support that, because it needs to. Do you understand what I'm saying?
Yep.
Right. That was let's the next time we review this, I want to see the previous design, because we seem to be going backwards from that in a bunch of places here. I mean, we do need to be able to have named edges here. That's going to be important in all sorts of kinds of trees. Does that make sense?
Yes, it's true that by changing to data structure, we have been limited in a number of ways.
So that's nonsense. That's the wrong way to think about it. Data structure needs to be extended. It's not difficult to extend. It needs to be extended to handle whatever you need to handle, right? And it could be that there's a pure tree data structure and there's a labeled tree data structure, for example, which are different. And you get to choose between them depending on what's actually in a particular tree. And if a particular tree, just like, if I don't know whether we have for graphs, whether we have different representations. I don't even know whether we have different representations for different kinds, but we might have. You see what I'm saying?
Mm-hmm.
Right. So here, this should be able to be an association. And again, we should be able to match against those things. Now, in terms of I don't understand your comments about tree traversal order, given that we have, oh, wait a minute. So there's the question of, does a tree, if we've got a tree with 3 legs, so to speak, and the match, I see. So in the original, that's the great thing about tree element, is it's very clear on whether it matches. So in other words, if you say, I want to match all those nodes that have three, three children, so to speak, right? I could do that by saying tree element of blank, comma, I could just use the pattern tree element, tree element blank, 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 if I wanted to, right? That would mean all tree nodes that have, so what I'm trying to match there, to be clear, is I want to match the tree element, which means the subtree, right?
Mhm.
Different from if I wanted to match just the payload, then what I would do is I would say X blank here, and I would say arrow X. And then I would say cases of that, and then I would just get the payload without the subtree. See what I'm saying?
Right.
Yes?
Yep.
Yes, I think we have currently the function tree select, which is able to act on the subtrees and get them depending on various criteria, but not two cases.
Right.
But
I think we
can do
need this, and we also need to be able to deal with, if you had something where you had a labeled, if you had a 2-arrow blank, et cetera, here, right? Where actually, even if I said blank arrow blank, X blank there, it's a bizarre case, but you see what I'm saying? And that will work with association matching. Okay. So, okay. So let's go down here. Should tree extract support general expressions? What does that mean?
So tree extract only accepts a tree in its first argument.
I would think probably yes, that's a good idea, but I'm not wedded to it. I don't know. Okay. I think that's a detail. That would be a courtesy of accepting an expa. I don't know. I think that's iffy.
Yeah,
I think
I agree. It's a detail, but it's also a tricky detail. So that's why.
Well, don't worry about it, because I think that honestly, if that expa, what I worry about is that rules tree and so on, and expression tree, all those kinds of things, they accept different kinds of inputs, and you'd end up with some bizarre heuristic that tree extract has to say, oh, I've got a thing with rules in it, so I should do this. I think it's a slippery slope and probably one not worth going down. I think let it be a tree for the time being. If there's a good courtesy thing to allow it to be without you having treeified it, so be it. But let's initially plan for it just being a tree.
Right. So there's only 4 functions right now that have a courtesy of accepting something other than a tree, and they're natural in those situations. So.
Well, I mean, things like rules tree obviously accepts rules.
Right. It doesn't expect you to be giving it a tree. It expects rules, but like tree insert, if you try to insert 2 at a position as a courtesy, it creates a leaf with 2 in it. And
I think that's okay. Yeah. I mean, because we don't really have a way of
same form as in rules tree or a tree itself.
I'm sorry. I don't think, well, whether you accept rules tree as a courtesy, I'm not certain. I'm not certain that's a good idea. Probably it is, but I'm not absolutely certain of it. Okay.
Before we move on to the next section, there is this nice idea of tree path containing data. So the idea is that tree path, it's moving through the tree structure, and then at some point you say data, so it moves on to the payload of that node, and then you can continue inside the payload.
Okay, so that we don't really have that notion for an association, for example. Do we have that notion? We don't have for a function. We have the notion of going to position 0, which goes into the head, right?
Which is, I'd say that corresponds, because this is what the default expression tree would do, is the data would contain a tree corresponding to the head.
Yeah, I understand. But if you happen to have a named element of the association, that is the tree, then you're toast, right? In other words, if the subtrees, if one of the subtrees was called the data subtree, you're toast at this point. See what I'm saying? In other
No,
words, what?
no, I don't see. Why is that?
Okay, because tree path tells you which subtree number you're going down, right? In this case, right, this is subtree 1, this is subtree 2, right? But if that was a named, if this was an association of those subtrees, right, and the key of that first association with data was data, you would go to the wrong place.
I see.
Okay.
Wouldn't we call it key of data?
I think reusing key might be a good idea, because key is a thing that is meta, and if you name a key, well, you get what you get.
Key is how you originally designed tree element to do this.
Thank you. Well, how about we go back and look at some of that design? We did a lot of work on it. Okay. But there was probably a reason for that, right? So you removed that, but did you know why you were removing it? The key wrapper.
Well, so
no, you don't know why you're removing it. So it was a good idea not to.
The intention was to first implement this using the tree data structure that has just a list of children.
I don't care. Let's not break the design because of some implementation detail right now. Okay, so don't break the other design. The other design was thought about for exactly this reason.
Well, I haven't broken the design, I don't think.
Okay.
The idea was to be able to add association later.
Okay, but this would break that by not allowing that, right? But I mean, what you're describing is one of the things I don't know how to do is some in an association, how do you get into the name of the name of the element? I don't actually know. Do you understand what I'm saying? If you wanted to do this exact same operation, you're walking down a list of associations of whatever, right? And you say, now I want to go, if I was doing that in functions, I know its position 0 of the function is the head. Do you get what I'm saying?
Yes.
I don't know how you do that with associations. And the fact that we haven't needed that for such a long time is perhaps interesting.
The situation here is different because here we need a variety of keywords.
I agree.
Like children, parents, siblings.
Yes, we do. We do.
And that's something completely new in this framework.
Yes, I agree. We need something which is I mean, look, it's not completely new. We could imagine a siblings concept. This has to do with, things like map are a very depth first creature, right? They just go down, they look at an element, they deal with that element. It's very local, right? We could imagine a non-local map which asks for siblings, where you go to a given element, I don't know whether it's map or something else, but you go to element 235 of some expression and you say, give me the siblings of that element.
So the only thing we have which is similar is all. So you can do 2, 3 all. So here we could have all is a bit like children. So we have 2, 3 children is more or less equivalent to 2, 3 all.
Well,
but here we need more than children.
Yeah, right. So I think it needs to be something which is a symbol, because I think that we're going to end up with
I mean, maybe I missed something, but if we're talking about all, I mean, aren't the list part specs siblings?
No, I think the issue is if you think about map,
okay,
you're at a particular, and I'm not sure whether,
I mean, map is at a particular depth.
Right, but the issue is, in a tree, I want my second cousin, right?
Right. So you first identify
saying?
Some element inside the tree, and then from that one, you want to refer to some family.
Right, so the question is, in an expression, If I have element 1, 2, 7 of an expression, and I want its second cousins, we don't currently have a way to do that. We could have a way to do that. I mean, its second cousins are, we go up 2 levels on the tree, and then we go back down again.
Exactly.
Right? And that's not an operation that we found terribly useful for expressions. We certainly could have it. I mean, it would be perhaps interesting to implement some WFR function that's based on the stuff we have in Wolfram Alpha for genealogical relations. Although genealogical trees are yet different because at least for, us higher forms of life, we have 2 parents, so to speak.
Right, but the terminology here in trees is still genealogical, mostly.
I know it is. I know it is.
It's some sort of tree of one parent.
Right. Right. I mean, part of what we're trying to do, long ago in the XML world, there were things like XSLT and the whole XPath mechanism and so on. And clearly everything that is clean there, we need to be able to do cleanly with, for example, pattern lists in the list of, I want element 1, 2, blank, 7, et cetera, et cetera, et cetera. We need to be able to, and that should be very straightforward. If we do that correctly with tree elements, we should be able to match either on the head tags or on the subtrees, if that makes sense. There should be a way of getting a path where you say, and I think this is what you're trying to describe here. Yeah. Okay. I mean, because the XML case is a case we need to.
Yeah, we have looked at XPath and we try to imitate all these family relations, which are new.
Tree children. Okay, this is ugly. This is definitely ugly, and I think we should try to avoid it. I don't think this is a good idea.
We can have lists as usual.
Yeah,
it's just that
I think that we should have lists. I think lists are more useful. I think that way we have interoperability with expression, extraction, et cetera, et cetera, et cetera.
That's true. I mean, we will run again into what does it mean questions as we have in extract, but it's fine.
Yeah, I mean, so here among the pigs and hippos, which ones have a maximum speed? I wonder if a hippo has a maximum speed more than 5 miles an hour. Well, I guess we get to see here. Is that what's that?
I'm quite sure they do.
Is that right? They're very big. That must be a lot of momentum. Okay. Antelope's better. Okay, so this has many levels on the tree. It both has the higher level of all the antelopes and the low level specific antelope, the specific gazelles and things. Okay.
Hippos have a land speed of 30 miles per hour.
Okay, that could be okay. Wow.
You can't outrun them.
Huh. Wow. 30 miles an hour. My gosh. And there, I thought I was the Greek hippopotamus, river horse. I thought they only hung out at. Never mind. Let's not go
faster in the water.
No, that can't be. They've got to be hydrofoils or something. Anyway, I don't know. Okay. Well, one learns something new. All right, let's just take a look at a few of these examples.
Okay, I was mistaken on that last point.
I would think so, yes. That's the speed of a... Yeah, anyway. Okay, so... What the heck is this? Oh, that's drawing a graph. Wow. What is that? I didn't know you could do that. Draw a graph. Is that obvious that you can do this?
It's something that geographics can do. I mean, Brett is now working on a geograph plot function, which will do better. And that's what we will expose. But geographics can do graphs, yes.
I didn't know that. Okay, family tree. Okay. So here what you're doing is, so I mean, right now the entity system,
So the key fact here is nest tree. So we first construct this children function
Oh, I
that
see.
iterates entity value. And then because it takes some time, that we have the uniconized form of the whole
Yeah, okay,
resting.
fine.
So this
Okay.
is getting the place of birth of all the nodes.
Right. It's interesting. So one of these is like Elizabeth II or something, is that right? Somewhere down here. Or maybe there was a break in the whole story.
Mhm.
I mean, is that this Kings of England type deal?
Right.
Kings and Queens of England. Okay.
So this is an example of more complicated cases in which you have to look at the whole family to decide the question. So we have a threefold which is able to do that. So can you explain this example, Ian?
Right. So what this is computing is the person in the family tree who was youngest when they had their first child compared to everybody else. And so the fold, like the analog with the ordinary fold, is when you're folding the list of children, you're taking a running maximum to figure out who the oldest child was. But the difference with tree fold compared to fold is that it has this fourth argument, G, that specifies how to combine the result of folding the children with the data in a node. And so at that point, you're comparing the age of the parent to the age of their oldest child. And throughout the course of the tree, you're finding the person who was youngest.
This is interesting, a tree outline. So this is another display form for the tree.
Mm-hmm.
XML.
We were thinking of allowing these to have a specification of what you want to start with. So it could start by opening some branch that you are particularly interested in.
I see. Yeah, well, why not? But I mean, also here, this needs to have some way of being displayed that isn't, I mean, it's a little bit, I mean, this is certainly a better way to deal with XML than we've had right now.
Right. So tree outline has optional arguments for like wrapper functions if you want to change what gets displayed. And somewhere I have a little toy of trying to display those as like actual XML tags.
Okay, this is amusing, but we should not worry about mutability at first.
Right. So we've been designing all the functions so that they will never mutate the data structure. And if there's any danger, they create a copy.
Right. And I mean, there might be a left-hand side where they do that.
Another thing that we would like to discuss with you is terminology, because we are confused about whether descendants means the subtrees, or it means the payloads of the subtrees, things like that.
All right. Listen, we have run out of time. I'm supposed to be doing another live stream about business and innovation Q&A. So I've got to go do that.
Okay.
This needs more time. I think you should schedule a 2-hour meeting to go over this stuff. We've got a lot of stuff to go over here.
Mm-hmm.
And please let's not lose the previous design with tree elements and so on. I think these examples look highly useful. We just should work them all through. And I'm optimistic that we're going to be able to do something really good here. Ethan is suggesting tree node instead of tree element. It's a possibility. Should write that down. It's not a terrible idea.
Earlier, when you mentioned having tree as the wrapper, I thought you were suggesting tree as the new name for tree element.
Well, it's possible that that's the right thing. Yes.
Nice to distinguish subtrees from end nodes in some way, so I like tree node better. Sort of denotes internal versus internal or terminal, I should say.
Right. There's a point from Ethan here on a live stream. Tree visualization should be made sensitive to rendering size. It's a pain to make graphs look good with appropriate fonts and sizes at different target scales. Yeah, that's a hard problem. It's a really hard problem. I mean, I've had that problem a bunch in things I've done with graphs of late. I mean, this is there's a lot of Ethan is complaining these trees look very early 2000s. Yeah. These are not the final design for trees. And yes, even tree form is a bit dated. Yes. Okay, I have to go. This is really. Can we try and get a 2-hour block scheduled ASAP to go on with this, preferably before I have forgotten everything that happened in this meeting?
Okay.
Yeah. Yep.
Okay. Thanks, and